So the use case I wanted to go over is diabetes prediction. You know, diabetes is a big issue in the Middle East in general. The challenge here we're looking at is trying to identify if a person is likely to be diagnosed with diabetes. The data set I'm going to use is a publicly available data. It's called the Prima Indian data set. So this is a type of, it's not a type, sorry, there are a group of Indian people in the United States, native Indians, and they have a special genetic configuration that's slightly different than the rest of the world. So they're a very interesting case to study from a biological point of view. Now, in this case, what we're trying to do is we're trying to identify who is likely to have diabetes way before they're actually diagnosed. So how are we going to go through that? I want to walk you quickly through the methodology that's typically followed in AI and data science. The first step is we obtain the data. After we've obtained the data, in our case, the diabetes data set, we clean the data. So this is called pre-processing. So here is where we make sure that the data we have is usable, has the right format, right structure, contains useful information we can use, and so on. Then we analyze. Here is where we look at the data. Just by looking at it, you can have some guesses and assumptions to if a certain property of a person, for example, their height or their weight, will affect their likelihood of having diabetes. After we've done that, we look at building a model that can help us do this classification. And once we build the model, we want to deploy the model. So one of the key differences between successful companies and companies that sometimes do not succeed is the last step. It's probably the most difficult step in the pipeline after pre-processing. So pre-processing is usually the hardest. Then you've got the second hardest is actually deploying it and managing the AI model once you've deployed it. In real life, you need to manage infrastructure, you need to manage compute power, you need to manage if you have your own servers or if you're using the cloud. In real life, you also need to monitor a few other properties of the model to make sure the model is not biased. It does not favor certain people over others. It doesn't favor, for example, simply because someone is obese, this person is likely to get diabetes. There may be a correlation and there may not be a correlation. So this is where you need to manage all this in real time as the model is running, as people are using the model. Now that we know the steps, let's start going through the data step by step. So the first thing is we want to understand what is the data made up of. It has the following features. So the number of pregnancies, glucose level, blood pressure, skin thickness, family history, age, and what we're trying to predict is the diagnosis. The diagnosis is simply yes or no. Yes if there is diabetes, no if there is no diabetes. Sounds simple. Some of you may have other thoughts to what other features may be relevant, but the research paper that used this data set did not consider these other factors. We'll just stick to them for the sake of the case. Now, some statistics about the data, a lot of numbers not relevant. The only relevant number here is this. So if you actually look at gender, you'll notice that the data set has only one gender. It's only females. So if you look at this feature from an AI point of view, it may not be very relevant to you because there is no information here. It's just everyone is a female, so it does not add any value to whatever prediction we want. So this is a kind of pre-processing we do to the data where we remove this feature because it's not useful to us. So in this case, we may want to consider removing gender. Now I'm going to walk you through a series of analysis and steps that you typically run through in a data science project. Again, all of this is, if you think about it, this is more the business side of data science and AI. This is where you understand your data, make sure it's relevant, useful, before you actually start building AI models. More statistics about the data. If you look at number of pregnancies and age, you notice that the majority have few pregnancies. Some people have 15 pregnancies. age, the majority are very young people. So here we might start to suspect that whatever relationship there is between diabetes and age, for example, may be slightly incomplete, because we have more young people than old people. Whatever AI system we train will, in general, because it's been taught on more young people than old people, will have this assumption throughout its lifetime. So maybe we need to start considering about being careful. Should we use age? Should we not use? Here, later on, I'll show you a few techniques which you can do, again, without code, in order to reduce this impact of age on the prediction. Next up, missing data. If you have a look in here, you see, for example, approximately 50% of the records in the dataset did not have their insulin measured. So you may start to suspect insulin may not be a strong, may not be a reliable factor, because we don't have a lot of data about it. So again, there are techniques you can apply in order to still use insulin as a feature, as a factor to whether someone is going to have diabetes or not, even though 50% of the data is not available there to tell you the answer. Next up, yeah, there are a few different features like that, just like insulin. So what we're going to do is just going to summarize some of the analysis we've done here. Is number one, we're going to look at missing information. There are different ways to handle that. Number two, we're going to make sure numbers are numbers and not number is not a number. And maybe think if we can come up with combinations of these features. Maybe there's a combination between age and the gender of a person. If we mathematically combine them, somehow it gives us more information. That could be something. Or we can maybe look at mathematical transformations here. And finally, this is another technique which you can use. Let's say you have thousands of different features. You may want to reduce the number from 1,000 to maybe 100. So these are all techniques which typically you'd have to run on the data first before you start building any model. And as you can see, I've spent a lot of time going through this, because in real life, when you're working with data, you will spend a lot of time working on this. Yes, sure. Yeah, sure, go ahead.
You said increasing the number of features from 1,000 to
reducing the number of features. Features as in insulin, gender, thickness, and so on. Typically, the less, the better. Sometimes the more, the better. So it's a guessing game / from experience, you would know this. All right?
You don't need a background in coding, but you do need some...
Yes, absolutely. It's more important, not statistics, but knowledge of the business itself, of the case. So actually, it's more important to understand the case than to know how to code. Because I will show you now, probably 3/4, if not 90% of you can replicate exactly what I did if they know the data. That's the only difference, okay? By the way, if anyone has any questions, just stop me anytime, yeah? Now we want to build a model. Again, as you can see, there are so many types of options. Now this type of problem, we call it binary because it's yes, no. There are other types of problems you may have to solve. And each problem has different alternative types of models you can use. The model is essentially the part of the AI system that will give you the answer. So we ask a question, does this person have diabetes? The model will tell us yes or no. There are, in here I showed you 4, but there are tens and in some cases hundreds of different alternatives. You have to make a decision on which one to use. And this is a very challenging aspect of the job of a data scientist or AI engineer. Typically, what decides a good one versus a good scientist versus a bad one is their decisions and what to do with the data and what models to select. This is what differentiates between a good one and a bad one. Then, once we've done this, we basically build a system. We build a flow. The flow would first pre-process, clean the data, build the model, deploy the model, and manage the model. So deploy and manage are probably some of the things many companies and businesses tend to ignore, because once you've built a system, over time, the system's performance will go down. It will start making mistakes. It's a fact. Unless you continue maintaining the performance of the system, unless you check for example, bias and drift. So these are concepts I'll cover in a while. Unless you check for fairness, and unless you monitor the logic behind the system, even though the system may give you a correct answer, it may give it to you because of the wrong reasons. So it's very important, once you finish building something, you keep looking after this thing. And at the same time, you want to look at the infrastructure, the servers, all the compute power, resources used to manage. So it's a complicated process that never stops. Once you have a model, you need to continue looking after it. Okay, so in essence, this is the flow we're going to go through today. I'm going to show you first the option with code. Sure, sure. No, so this is the interesting thing. There are models that are rule-based, yes. For example, I'll show you one of them here. The decision tree is probably closer to rule-based models. But there are variations of this that are further away from decision and closer to complex mathematics. It's educated. It's not pure automation. There is an element of automation. There's an element of educated guess, and there's an element of statistics in it. It's a combination of all of these factors together. Okay. Yep. Any questions now? All right. So I'll go through the. So anyone here knows how to code? Just a quick show of hands. 3 people? Okay, amazing, good. So no one will understand what I'm doing if I make a mistake. So this is basically code with some comments around. I'm gonna, does it show in here? Maybe if I, can everyone see this, or it's a bit small? That's better? Yeah, okay. So in here, I'm gonna go through exactly those steps in code and just try to imagine the complexity involved in just thinking about how to write this code. First off, I'm not gonna write everything from scratch. I'm gonna use some work that has been done by others. These are what's called libraries. They help you basically reuse code. Here I'm loading the data. This is how the data looks like. As you can see there, these are all the features in the data. After that, here are all the columns in the data. And I have a total of 768 records and total of 10 different features. So now I'm still trying to understand what is the data made up of. And it's a very important step. Looking at the data with your eyes can tell you a lot about it. Profiling. So now is where I start understanding the statistics and the data. Here's where I got the graphs earlier. I'm looking at simple average statistics counts, minimum, maximum. Here is where I noticed that there is only one gender in the data, which means gender is likely not useful. Then here is where I calculated the number of missing values. Then I'm doing something called correlation. So this helps you understand relationships between variables, between the features. This is actually very important, and doing it manually and taking decisions based on this is a very tricky business. Whereas if it's partially automated through an, let's say, auto AI system, it relieves some of these decisions which you have to take. For example, if you look at age and number of pregnancies, you see a 0.54 number here. It means most of the time, if age goes up, number of pregnancies goes up, or if age goes down, number of pregnancies goes up. It's a little bit logical. So this tells you these kind of relationships between the features. Another one here is insulin and skin thickness. So if the skin thickness is higher, you're likely to have higher insulin in your body. I'm not sure how biologically correct is this, but the data tells us there is this relationship. Even though it's not all the time, around 0.5% of the time, this is the case. So this is where you start understanding the data. This tells you that maybe these two features, you can use them somehow together to have a more strong, to be more sure of the answer you give at the end of the day. What do you mean? Is this relationship? Yes, yes, yes. Yes, sure. Yes.
You collect the data and put it in one Excel sheet, right?
Yes.
And use Python to find the relationship between
Yes.
two features, right?
And to build the model and to deploy. I will go through that. So I'm going to do everything in code. That's step one. Then step two, I will compare doing exactly the same without code.
Is this work for all the kind of
Code? 99% of the time, yes.
codes and attributes?
Yes, 99% of the time, yes. Okay. Just some other visualizations helps you see relationships in the data. For example, you can notice here the skin thickness and BMI. So BMI is a relationship between weight and height. There is some relationship between them. So as you can see here, as one goes up, the other goes up a little bit. So these are the kind of relationships you want to find in the data. The more there are, the better it is for you. And if there are no such relationships, you can create one by doing some maths on the numbers. So maybe applying a mathematical function on one of those features will create a relationship. And this is also a good thing you want to look at. More relationships. Then, once we've understood the relationships, we start building models. Here, I'm going to try 4 different models. I'm not going to go into the math details between them, just 4 basic models. Not basic, 4 very common models. I tell it here what's input and output. As you can see, output is the diagnosis. I'm predicting diagnosis. Input is everything except diagnosis and gender, because we notice gender is useless. So input is everything except diagnosis and gender. Output is diagnosis. So an AI system, a model, is simply input and output. Here is where I train everything, and this actually takes time. It's not instantaneous. Then I calculate some results, and now I've got the 4 different models. Each one has performance. Let me zoom in a bit. So you've got 4 different models. I'm measuring 4 different. So let's focus on accuracy here. The best one so far, the highest accuracy. It means 75% of the time it got right, the answer. It's what's called the logistic regression. For those of you who are familiar, this is the simplest model you can come up with. There is nothing simpler than that. So this problem can be solved using the simplest model out there. It's outperformed some of the other models. So now as an AI engineer, you'd want to take this model. What you have to do now is you're only halfway through. I didn't do this in code because it's going to take ages to go through. What you'd have to go through is take the model and optimize the model. So a model has certain features in it, certain parameters, certain number of variables in it. What you want to do is you want to make sure you're using the best parameter. For example, if we take a decision tree, if you're familiar from the picture earlier. So if you look at this decision tree on the left, or in the middle, sorry, you can control how deep it goes, how wide it goes, when does it split. So these are things you can control about a model. And trying to find the best combination is probably, I mean, there's a whole job called machine learning engineer, and their job is to find the best combination. And it pays really well for those interested. So, yeah, anyone had a question? Sorry, yeah. So now that we found this is the best model, we have to optimize it. I did not do that. Then you would save the model. Here is where I'm pushing the model to a server. I don't want to show my credentials. Save it, give it a name, and the model is now available on the server to use. So there's infrastructure taken care of. You need to take care of infrastructure. You need to take care of access to the service. How would you call the model? So now you have a machine learning model. You give it input. Think of the input as, you know, details about a person. It returns an output. The output is diabetes, yes or no. You need this somewhere so that you can use it in your business. Maybe in your mobile application, in your website, or in the backend systems of your business. So you need to expose it in a way which you can use. You need to also manage all of that. So there's also more complexity involved here, and it's an entirely different line of job you can work at. This is through code. Now, want to go through something similar, but using Auto AI. So I'm going to skip through the process of this, but of signing up, sorry. It's actually, Auto AI is a tool developed by IBM Research, and it's now part of the IBM Cloud platform. What you can do is, you give it the data, it runs the analysis, it identifies what features to use. If there are some mathematical transformations that have to be done, it runs through them, tests, finds the best ones, then builds the model, finds the best model, optimizes it for you, then deploys it for you, and manages the infrastructure for you. So it does everything in few clicks, as you'll see. This concept, only for structured, there are alternatives for images and text. So the concept exists for text and videos. The whole idea is called democratizing AI. And that's what everyone's doing. Google's doing that, Amazon's doing that, Microsoft's doing that, Oracle's doing that. Simply because there's a lot more demand than there is supply. People need AI in their business to win, to bring value. And there is not enough skills out there, and maybe for the coming 5-10 years there will not be enough skills to satisfy this demand. So the alternative is to enable the people who are not technical to build AI systems and to benefit their business. So let's quickly go through this. Yes. Yes, I will show you the Excel sheet. As a matter of fact, yes, here's the Excel sheet. Yeah, I mean, even that, I mean, business people, yeah, yeah. All right. And just by looking at the data, you can see the anomalies I mentioned. Empty values all around, gender is all female, and the relationships, you may not be able to visually see them, but at least these basics you'll be able to notice. 768, I think. Yeah. Diagnosis is yes, no. It's basically, does the person has diabetes, yes or no? Yeah. Better. The larger, the more, the better. So you need to somehow structure it, to some extent. Minimum table of features, records. That's the bare minimum you can do. Even in data science in general, data science work really starts once you have a table format, or once you have a collection of images, or once you have a text. So these are different, you know, you can think of them as verticals in data science. You've got structured data, such as this. You've got images, text, video, audio, and so on. They all have similar approach. You need to look at the data, clean it, make sure it's usable. Once you've done that, then you can start the data science process, the building the AI model. All right? Everything. So until it loads up, I'll tell you a story. I was once running a session with a client, and I walked them through. So just a second. Here I'm defining the server requirements that the system is going to run on. This is how much power it's going to use. I'll give it a name. Create. I'll tell you the story in a while. Here is where you upload the data. Just going to select this data. Now, on your right side, you'll see the list of features. You're going to tell it what are you trying to predict. You're trying to guess the diagnosis, you see it automatically detected the data types. Some configurations, so I'm not gonna go through these configurations, but the most important one is the prediction type, classification, yes, no, binary, yes, no. This is what we're telling it to do. It's gonna monitor something called ROC AUC. It's a measure of how well is the model distinguishing between the yes and no. Because what sometimes happens, if you say everything is a yes, you can get a really high accuracy in your system. So in order to avoid this, we monitor another metric instead of accuracy that measures how well is the model distinguishing between the yes and no. Then run the experiment. This is gonna take a few seconds. Until it's done, I'll tell you the story now. I was running a workshop with one of my clients, and I was doing exactly what we did. They were technical developers, so I went with them through the code. They wrote the code themselves, and they built the model and everything. Then I told them, everything I've been teaching you the past day is useless because now you can do it with 1, 2, 3, click, click, click. And they almost started cursing at me afterwards because we spent the day teaching them something that now you can do with a few clicks. So technology nowadays, I mean, today they were talking about skills. It's true, machine learning skills are required. It's true, data science skills are required. But now, not just those with the skills have the opportunity to use AI. Everyone has the opportunity to use the AI. That's the only difference. Yes, sure.
When you use, let's say, IBM or Microsoft Azure, it stays with the person who has the data.
So this differs from Microsoft to IBM to Google. Google, any data you give them only in certain, I mean, most of the time, the data you use to train, they can reuse to train, most of the time, for Google. But for IBM, the data is yours. If something goes wrong to a level we can't access and help you figure it out. So that the data is your data, we have no access to that. That's for IBM. So they're very big on this aspect of privacy. Microsoft is a bit of a gray area. In some cases, yes, some cases no. Sometimes they don't mention. So I can't answer that. Yes, I'm talking about that as well. Yeah. So there's a free tier. You can all create an account. I'll show you the link now. You can use it for free for as long as you want, but I think only 50 hours a month of compute processing time. 50 hours a month of processing time. Free for as long as you want. The payment tier is per API call and per training hour. That's usually how these are measured, per training hour. How long does it take to train your model on the infrastructure? And it's, by the way, very cheap to the extent, I mean, across all cloud providers, it's so cheap, it's even cheaper than getting your own servers. Most of the time for startups, it's much better to use one cloud provider than build their own infrastructure. Some companies never do that. I'll give you an example. Which company was it? There was a company, a startup. Which one was it? I think Uber or Lyft. One of those ride-sharing startups in the US. They're a $1 billion company and they still use AWS. They have not migrated to their own because it's simply, it's not their business to run these infrastructure. So give it to someone else, let them take care of it. I'll just teach my people how to use it. Yeah? Do you have a question? Yeah. I'll show you how to do that.
لازم ارفع الداتا جديده مع الداتا القديمه ارد اعمل له ترين ثاني مره.
You don't have to retrain, you have to, well, we call it retrain, but you don't have to start from scratch. Okay. You build on top of what you already built. Okay, so I'll show you as well how to do that here. Let me quickly go through the pipeline. That's exactly what is visible from the back. No. Yes, sure.
Wait.
Is it available for me to integrate?
Yes, yes, as an API.
Of course, to Watson whatsoever.
So I'll show you the process.
Is there a way to download it and use it?
It's a tricky question. Not yet. Not that I know of. I've been asked this before and not that I know of. Because, let me think. Let me get back to you. I think we'll get to something similar. It may answer your question. Yeah, just remind me at the end if I forget you, please, okay? We'll get back to you. So first step, I don't know if you can read the text, read the data, read the training data. It does the pre-processing. Here is where it does the cleaning. Then it does model selection. It selected logistic regression. Then in here, so this, the model selection process is, in my case, I only had 4. What I did is I compared the 4 against each other. There's more to it than just comparing the 4. You need to compare the 4 across different metrics, not just accuracy. Then the best model, you optimize it. You do the feature engineering. This is where I spoke about using math to improve the performance of the model. Then you optimize again. So you've got 4 different levels of optimization. And these are the performance of the 4 different models compared to each other. And you can see it's actually slightly better than what we have in the other approach, simply because we optimized. So P3, which is the model with two levels of optimization, was actually better than the rest. If we have a look at the model, it will show us what are the steps it took to get to this performance and to get to this model. So here is the evaluation, how much it got right, predicted versus true. Let me so predicted versus observed, how much does it get right? It shows us on the evaluation, and the more important things are down here. The transformations. So this is all the math it's applied on the model to create new features. For example, it just applied to the square root on the glucose level to give you a new feature, and it turns out this feature has some importance, and it's actually more valuable than just looking at the glucose level on its own. What it did is it did something called PCA, and this is a technique to reduce the number of features from, let's say, 1,000 to 100. What it did is it used PCA, and there is this reduced number of features, it added it again to the model. So now instead of having 10, you will see the model has 16 features. So there are a total of 6 new features it created and added to the model. And if you look at the importance, added, not replace. No. So you'll see it'll add and drop. In some cases, you'll find both. Here you have glucose originally, and you have the square root of glucose. Both are useful. But there are situations, actually, if you look around here, you'll see gender is not around, because it dropped gender is useless. So there may be situations where you have to drop. There may be situations where you have to keep both. So again, it's very dependent on the model and the analysis you do on the data. List of features. All right, so once all is done.
Excuse me?
Yep. Yeah.
Can we get the code underneath auto-generated?
I'll show you now, yes. You can save it as a notebook. This gives you a code, something similar to what I showed you here.
So still can be edited and taken to some other nodes?
Yes. You have some control over that, yes. I'm going to save the model. And once it's saved, it's saved in here, and inputs, here are the inputs it's using. And this is where we expose it as an API. For those of you who are not familiar with the concept of API, let me just name this. So give it some time. For those of you not familiar with the concept of APIs, it's basically for you to be, it allows you to call the model or call a certain function on through a web application or through a web server or through a mobile through code. So it's the way of exposing certain functions to be called across the internet from somewhere. So what it does is it gets the model, it traps it with it automatically handles the wrapping of the model with code, and then what it gives you is an API which your developers can now call and use the model. So here's an example of how you can call the model. So it's simply calling this URL in here. So the model is now on this URL, and all what you have to give it is you have to give it the inputs and examples of the inputs. That's it. So now your model is ready. Few clicks here and there, save the model. All the process we've gone through in code, from developing the statistics around the model, to understanding what features to use, to transforming certain features and so on, to selecting the model, to building the model, optimizing it, and finally deploying it in a few clicks. So this is pretty much democratizing AI. It gives you the results. You can get the code of the process of how you did it. Yeah, I can show you. Let me show you. What do you mean? Yes, but so this is designed for people who are not going to learn. There are people who basically run businesses. Their job is not to build this. But if they want to build, they can use this. Yeah. So there are tools for deep learning. Very similar concepts. It solves a different problem. That's the only difference. Machine learning, it's usually better when you have structured data like tables. Deep learning usually is better when you have images and videos and so on. That's probably one of the key differences. Yes. Yeah, it's usually better on unstructured data. It's downloading now. Okay, so let me show you the notebook here, the code generated.
Here's a question.
Yeah.
What affects the time needed for making the model?
Sorry.
Before we run.
Yeah.
What affects the time that we wait?
The number of records and the number of features. That's it. That's it. Yes. The data you give it is what defines how long it takes to process it.
Can we know the time before we run?
Very difficult to guess. Even if you're doing it on your own infrastructure, it's something very difficult to guess in general. Yeah.
Excuse me, can I ask something? Sorry, if you want to take it. So what if the data has been updated? Do we need to go into the process again and creating a new model and a new API, or it's going to be done once and then we're done?
I'll answer this in a few seconds. I'll get back to this point. The next thing I will show addresses this problem and his problem as well. I'll get to both answers at the same time. Yeah.
أنا صراحة عم بدور على نفس النقطة بين ال own tools أو ال cloud solution. من خبرتك إحنا شفناه أخذ maybe 5 minutes قبل ما خلص العملية كلها.
لا minute maybe closer to a minute.
لو بتعمل هذا نفس البروسيس على let's say لابتوب i7 10th generation GPU 2060 for example كم راح ياخذ وقت roughly?
Because you mentioned the word GPU, it's a different answer. This usually doesn't run on GPU. It's simple machine learning. People don't run this on GPUs. GPUs are only beneficial when you have deep learning.
Okay.
But if you're talking pure compute power to compute power, here we define the infrastructure as 8 core, 16 GB RAM. If your machine has higher infrastructure, it will perform better. So it's all about how much you give it compute power. That's the only difference.
So في الكلاود
Another difference is the algorithms used to find the model and find the parameters of the model. So if you can come up with, or if you use an algorithm that's very highly optimized, you may be able to match the time. I'm not saying this is the fastest or the best.
انا اللي عم بحاول افهمه انه اللي مستفيده من الكلاود هون هي الالجوريثمز الجاهزه والبيلد اكثر منها كومبيوتنج muscle.
Yeah. Yes, it's all about ease of use. It's all about availability. It's all about resources, exactly, support. It's everything. Yani, compute power is not really the question here. This is the answer, maybe. Compute power doesn't really play a big role unless you start going into deep learning or huge data. That's when you can start talking about compute power. But at this level, few hundred examples, 1,000, maybe 10,000 examples, it's not a big deal. It's not a big deal, okay? So here's the code that describes the process that the model has gone through. So these are all the steps. Every line is one step in the flow. And finally, where's the saving? So this is the model selection approach in here. What else do we have? And yeah, so at the end, it generates a pipeline that contains all the steps. So whenever you give it data to test or to give you the results for, it runs the same transformations on this data and gives you the output at the end. Okay? The next step I wanted to go through is, now we have a model. The model is exposed as an API in here. Where did it go? It's here somewhere. So here's another example. Now the model is exposed as an API which you can use through code. And I've written here another sample code which you use typically to call this API. So few lines of code, give it an API key, and you send in a request. And the same request, you send it to this URL, you get back your results. Now, what you often want to do is once you have this model and this API exposed, you want to maintain it afterwards. This includes the retraining of the model. If you have new data, you may want to train again or test on the data. Sometimes you don't have to train, sometimes. So what you would do, there's a different tool, it's called OpenScale. And the whole idea behind OpenScale is to do all this management for you. Concepts like fairness, is the model fair or is it biased against people? Explainability, why did the model give you this answer? Performance monitoring, is the performance going up or going down? It doesn't go up usually, it only goes down. Is it going down or is it stable? And few other similar concepts I'll show you now. So you can, this tool you can hook up to some other service providers as well. It doesn't have to be the Auto AI. You can hook it up to any other, your own custom model or your, or Microsoft or Amazon or Google. Give it a name. What's this one? How are we on time? So now we're gonna select the model we want to monitor, okay? So this is the diabetes model we just published. Is it the same one? No, it's the one I published earlier. No worries. Okay. So here is where we define what is the model about. Is it's numeric and categorical. It could be text, it could be images. And it's binary classification. Next up, so in order to do this, I need to call the model once. Let me call it once. In general, yes. Most of algorithms that work with visual data automatically detect the features in the image. Most of them. No, we don't need any of that, yes. So now I want to test the model. So I want the same data. So what I'm doing here is I'm just going to call the API and just to just call it once so that the OpenScale knows that the model is active. That's it, just to validate. Let me just test. Just gonna run this once. It's running. My own internet. Yes, sure. So this all depends on the infrastructure you have. Can the infrastructure process things fast enough or not? So the answer, machine learning can. It depends on your infrastructure. If you have the right infrastructure to be able to process things that fast, then yes. What's up with this? Oh, sorry, my bad. Just a second. Yeah, so now it's testing a few examples. It's sending a few examples. And might as well show you the results, how it looks like. Let me show you how it looks like. Let's run this again. So what a developer would do is from a website or an application, sorry, forgot to save it. From a website or a mobile application, they will call this code. What they will get back is a result that looks like this. So in here, I don't know if you can see, but it gives you a yes or a no for every question you ask, and it gives you the probability of how confident it is in the answer. And confidence sometimes is important. If you have a low confidence in the system, it means you probably need more training data. So this is how the output looks like. Now we can come back here. I'm finished. Okay, next step would be to start configuring quality monitoring, to start configuring fairness, explainability, and drift. And I'll go through every concept as I'm talking about them. Model details, this is basically what are the inputs. I'm just going to point it out to where the data is. I have the data stored in a database. So here I'm telling the system, this is the data I use for training. And it's important because it runs some statistics on its own on the data to understand what is normal, what is not normal in the data. Okay, so now we tell it what is the data. It's this one. Here is the data. It's called diabetes data. I have it saved on the database. And now I tell it what are the inputs and what are the outputs. So the output is diagnosis. The input is everything except age, because we know the model dropped age. Sorry, not age. It's everything's gender. You're right. Next. Categorical data. So if any of these is not a number, but all of these are number, so it's fine. There's nothing here. This is the output, the prediction, and this is the probability of the output. Skip this. Now the system knows what are the features, the properties of the data. Here's where we start monitoring quality. Quality is all about making sure that over time, as you use the system, new data comes in. Now this data most likely is not the same as the data you used to train. People's behaviors change over time. Data changes over time. So for example, if this is a case of you have a second or a third generation of people coming, do you want to measure their diabetes? Their properties, such as their BMI and age and number of pregnancies, most likely will not have the same behaviors as the people who you trained on. So things do change. Here is where you want to make sure your model is constantly good enough so that the accuracy, for example, here is we want to make sure that the accuracy of the model doesn't drop below a certain threshold. So it's all about monitoring this during runtime as you deploy the model. Here is how many samples do you want to evaluate. So whenever we have 1,000 new examples, we test against. Now there's a risk if you're testing against every 2-3 examples, that these 2-3 examples you have are not normal. That's why we sometimes want to test against thousands, maybe hundreds of examples. Okay. Now we've identified quality. Fairness. Fairness is basically to monitor if the system has bias against a certain person or a certain profile of people. So if the model, let's say, I'll show you an example now. So first we want to tell it what's good, what's bad. It's good to not have diabetes. So a no is good. And yes, having diabetes is not good. So we tell it what's good and not good. Next step is which features are likely to have some problem in them. So by thinking, generally speaking, things like age, gender, nationality are things you want to make sure you do not have a problem against. You're not preferring a certain gender over the other. You're not preferring a certain age over the other. So the system automatically guesses that you have age in your data. So likely age will have an issue if you don't monitor it. So what we can do, we can select age. It's already recommended. Select. And it automatically does some math to guess what is normal, what is not normal. So what's normal is ages 21 to 26. Because they're the majority of the data, this is the normal. This is what the majority of the normal in this data. Okay, what's abnormal is there are only few examples between ages 27 to 81. Since we only have a few examples of these people, we want to make sure we're treating them fairly and we're not, discriminating against them simply because we don't have enough data about them. And this is a very big problem, especially in cases that have to do with, gender and nationality and race and group. An example that occurred a while back in the United States, police department was trying to predict a person's likelihood to reoffend, to commit a crime again. So since, unfortunately, the majority of the population who committed crimes again were African American, the model, because it was not trained to handle this majority, so anyone who's African American was directly assumed to be, a person who's likely to recommit a crime, even though that's not true. But simply because they were the majority, that's what the model thought. So here is where we try to prevent this from happening.
How do you prevent? Do you, in the coming data, do you need to instruct whomever is getting you the data, please bring up people?
That's one way. That's one way. The other thing you can do is there are certain mathematical functions you can apply to the model or to the data to fix this. Yes. That's one example. Weighting is one example. It works in certain situations, yes. So instead of you trying to guess how to handle the situation, this handles it for you. Threshold 80% fair. Evaluate every 1,000 examples and save. Explainability, already spoke about this. Here is where the model tries to explain why did it come up with this answer. So this person is likely to have diabetes. Why? Is it because of this and this, or that and that? So this is typically something easily available. There is a lot of research onto this, publicly available, but very few tools actually do that. So in terms of research, in terms of code development, you'll find a lot of resources. But in terms of tools, there aren't many. Finally, drift. This is basically the concept of change of data I spoke about earlier, how data changes over time. This is where it monitors and detects if the data changed. So at first we were only monitoring the accuracy, but now we are actually monitoring the data itself if there's a change. And I'm just gonna click through this. If there's a 10% change, every 1,000 examples. So now we configured all these concepts. Imagine having to write code to monitor all these different concepts. You'll probably need an entire application on its own just to monitor these different concepts. It'll take some time. Yeah. Yes.
So I'll just upload the dataset and then choose the model.
Or if you have an application or a system, you can point your system to this model, and through code it will just call it. Okay, 5 minutes. Hope this finishes in time. Yeah. Yes. Yes, yes. Okay. Yes. Time series, no. It's a whole domain on its own. Deep learning, yes. There is something exactly the same for deep learning. Just to answer the question, there was another question here. Let me just quickly answer this. Yeah, I will get the links are next page. Don't worry. So there is the option of going everything open source code or going through tools. These are just names of tools. As you can see, you can either run everything through tools, or let's say you have people who know how to do the data science part, or you have people who know how to do the machine learning part, but don't have people who know how to do the production part. So it's all about selecting the block which you don't have, and then using this. So for example, you have a whole team who knows how to do everything except build a model. So your team does the data science part, you use Auto AI to build the model, then you can deploy on your infrastructure. If you don't have any of these components, it's all about finding the right tool which does the job for you. And this is the concept of democratizing. A free tier, it's not about the APIs. Yeah, it is. It's five free models. I think five. Don't take my word for it, but I think 5. Links. These are the links. So the documentation links have, the material has a link to the slides as well, and has, it has the code, the slides, the data, everything's under material. The documentation links are basically, think of them as tutorials on how to do what I just did. And then you've got the sign up link. Yeah. Yeah.
And then you rely on certain classifications of ethnicity, black, white, etc. And sometimes these ethnicities, these classifications might not be fair. Like, for example, Middle Eastern people right now, for some legal reasons, are classified as whites in the United States.
Yeah, okay.
However, that classification for specific experiment might not be fair. Is there a way to measure the fairness of the classification?
Of the classification itself,
Yes.
yes. Unfortunately, it's a very difficult thing to do. It's incredibly difficult to quantify this unfairness. It's doable, but it's maybe sometimes easier to fix the classification system than to fix it through code and maths.
The reason why I'm asking
Yeah.
is there's a real, I think there is a real issue with companies that do ethnicity classifications based on DNA analysis. They have reference ethnicities, and whenever someone I noticed, like from the Middle East, test with them, and because they don't have enough data from the Middle East, it's mistakenly will classify them
Absolutely.
like 30%, 40% Europeans,
Absolutely.
and that's a big thing.
Simply because they did not run this. So all the concepts I spoke about fairness,
Yeah.
simply because fairness is a very new concept. AI ethics is very new, and fairness falls under AI ethics. There yet isn't enough tools out there and enough awareness out there for people to understand that you need to be careful about these things. Building a model is not just about building it and using it. There is more to it than that. Yeah, absolutely. It's a huge issue. 3 minutes, okay.
Will you be able to see data visualization after you run this?
There is a tool, I didn't go through it. There is a tool though. If you go to, it's called embedded dashboards. If you sign up and go to the documentation, just look for embedded dashboards, it does what you're asking for. Yeah.
Can we use clustering to solve the fairness issue or human judgment?
I cannot give you an answer. Depends on the case. Certain cases yes, certain cases no. It's a tricky question. Yeah, there is no one answer to it, to be honest. Yeah.
I wanted to ask: is there any in the system can show us if there any error in the coding in the model?
What do you mean?
The algorithm. Can the system show us if there any error in the algorithm or in the model or in the code?
So if you built everything through the system,
Yeah.
it has its own checks. It makes sure there's no errors. But if you built it, it's very difficult to know where's the error. That's something to keep in mind.
Okay, thank you.
Yeah.
All this is fine and nice and beautiful and everything. I like it. I really do. But for professionals, how much control does a professional machine learning engineer lose when using Watson? Do I still have? Can I still fine grain, go to the deepest, nittiest, grittiest parts of the system and tweak them?
To be honest, many professionals hate Watson and their friends because they don't have the level of control they want of the system. Typically, even to some extent, I don't hate it, but sometimes I prefer to do my own development simply because of the level of control I have. But professionals have the skills needed. This is not aimed at professionals, so that's fine. So yeah, you have certain control over certain things. For example, how much fairness are you willing to accept in a model? You have control over that. But a professional may want a lot more control. They wouldn't come to us and they'd write their own code. That's the only thing. Unless I was chatting with a friend of mine the other day. He works in a big organization. They built something equivalent ground up using their own code. And it's incredibly difficult to manage. Sometimes a professional will have to accept that it's a trade-off between time and effort versus ease of use and flexibility. So as an organization, are you willing to invest time and effort in maintaining all this control over the model?
إذا في عندكم أي أسئلة بتيجوا تقدروا تسألوه بعدين يعني.
I mean, we can chat outside when you're done.
Yeah, okay. يعطيكم العافية.
Thank you very much.